5, evaluating predictive performance. This is probably the most important chapter of this topic. We need to have very good understanding of could get little in the weeds a little bit, but you need to have an overall understanding because this is the basis on which the rest of the models we're going to look at will compare. So we're going to look at, well, why do we want to evaluate? Because there are multiple methods that we will be discussing: decision trees, neural networks, logistic regression, and so on and so on and so on. And in each of those methodologies, there are parameters that we have to tweak. So you literally end up with a whole bunch of different possibilities. So there must be a way of comparing all of these different models that you fit, which could run into tens or even sometimes hundreds of different models. There must be a way of comparing these models and then pick the best possible model from all of the different alternatives that we have considered. So that is the basis, that is the reason why we need to evaluate for each method, multiple choice, so the best model we need to assess the performance of each model. Okay. Now, we can look at performance evaluation under two major categories. One is interval target. It's about target. Okay. What kind of target do we have? Target is the dependent variable or the y that we are trying to predict. Okay. If that y is an interval target, then we have certain ways of computing performance accuracy. We want to see some. Okay. And then when you have class target, usually binary between yes or no, success or failure, that kind of stuff. So if you have class target, then the accuracy measures that we use for interval targets could be used, but they are not very useful. We need an entirely new set of ways to evaluate performance. So we're going to look at two different ways or two different kind of methods. So we'll first start with interval target. And as you will see, we've already seen this in chapter 2. Okay, so we have fit statistics, so that gives you how well the model fits the data. So if you have a regression model, then that would be how close the points are in 2 dimensions. If you have a straight line regression, how close the points are to the straight line. So that gives you the fit statistics as a goodness measure, goodness of fit measure. Then there is another one, which is how well a model that fits the trained data very well, how does it actually perform when we actually use it for prediction? So that's where our validation data sets come into play. So you take the training model, apply it to the validation data, and then see how well it performs in terms of predicting new observations. Okay. And then there is one which we have not seen, and that is what is called list chart. Here, we are really not interested in predicting a particular value of y, but we want a ranking of y. Okay. We'll look at an example of when that ranking will be. So it will be like if you evaluate, say, price of some product, okay, and you have lots of alternative, but you want to sort it by the price. You want the cheapest products at the top, and you want to select those cheapest products. Now, if you're selling the product, then you want to list the products in terms of price, and you want the most expensive product. So you're really not interested in predicting the price of a particular individual product, but you have a list of items and you want to sort them by some target value. So in that case, the actual fixed statistics doesn't make any sense, you have what is called lift charts. So these are the three things that we're going to look at for interval target, and then we will look at class target. So here are some list of accuracy measures for interval target, which can be used as a fit measure. You apply this to the train set, the data set from which we develop a model. So that will give you the fit statistics from the goodness of fit perspective. Okay, you apply the same to the evaluation set, so that will give you accuracy measures from the prediction perspective. But pretty much the same thing, so mean error, mean absolute error. So you must be familiar with all of these error measures. We'll look at an example in Excel in just a second. Okay. And then prediction, one more thing that you can do, prediction accuracy is to do a plot. You can do a histogram and bar chart of the residuals. Okay, so that will give you some insights as well. And then we have the lift chart. So we will look at these.